This video is for Section 6.2, transforming and combining random variables. So the first thing we're going to talk about is the effect of multiplying or dividing by a constant. So we're going to start with a simple example of a discrete random variable. Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. The number of passengers X on a randomly selected day has the following probability distributions. He charges $150 per passenger. We're going to let C equal the total amount of money that Pete collects on a randomly selected trip. Because the amount of money that Pete collects from the trip is just 150 times the number of passengers, we can write C, which is the money that he collects, as 150 times X. From the probability distribution of X, we can see that the chance of having 2 people, X equals 2, on the trip is 0.15. In that case, C would be equal to 150 times 2, because we said we were using C equals 150 times X, which gives us 300. So one possible value of C is $300, and its corresponding probability is 0.15. If X equals 3, then C equals 150 times 3, which is 450. The corresponding probability is 0.25. Thus, the probability distribution of C is the following. So now, in place of where we had number of passengers and X sub I standing for the different number of passengers that we can have, and then the probability being P sub I, now we're going to be looking at C sub I, C being the cost or the money that's collected, and the probability still being P sub I. The effect on a random variable by multiplying or dividing by a constant. So multiplying or dividing each value of a random variable by a number B multiplies or divides the measures of center and location, mean, median, quartiles, percentiles by B. Multiplies or divides the measures of the spread, the range, the IQR, and the standard deviation by the absolute value of B, and does not change the shape of the distribution. For Pete's Jeep Tours, the variance of the number of passengers on a randomly selected trip is variance equals 1.1875. The variance of the total amount of money that Pete collects from such trip is the variance sub C, which is the money collected, which is 26,718.75. Basically, what we would have to do is we would say 22,500 times 1.1875. So that the variation of the money collected is 22,500 times the variance of the passengers. So where did the 22,500 come from? All it is 150 squared. So in other words, and the 150 came from the cost. So in other words, the variation for the cost is 150 squared times the variation for the passengers. Multiplying by a random variable, or multiplying a random variable by a constant B multiplies the variance by B squared. So now we're going to look at the effect of adding or subtracting. It costs Pete $100 to buy gas, or permits, and a ferry pass for a half-day trip. The amount of profit, V, that Pete makes from the trip is the total amount of money, C, that he collects from the passengers minus 100. So basically, the profit is going to be the money collected, which is kind of like the revenue, minus the cost, which is going to be 100. If Pete only has 2 passengers on his trip, so X is equal to 2, then the cost is 300. So remember that, or the money collected is 300, sorry. So remember that we get that by saying 150 times however many passengers he gets, and so if there are 2 passengers, then the money collected is $300. The chance that this happens is 0.15. We've already talked about that. So the smallest possible value of V, which is the profit he makes, is 200. Its corresponding probability is 0.15. If X equals 3, then the money collected is 450, and the profit would be 350 because we would have to say 450 minus 100 because the 100 represents his cost, so it would be 350. The corresponding probability is 0.15. The probability distribution of the profit is below. So if you think about this 0.15 corresponded back to when we originally said that the probability of 0.15 was when we had 2 passengers. So this would be 2 passengers. This one would be 3 passengers, 4 passengers, 5 passengers, and 6 passengers. All of these were our X's. The effect on a random variable of adding or subtracting a constant. So adding the same number A, which could be negative, which would be like subtraction, to each value of a random variable adds A to the measures of center and location, the mean, medians, quartiles, and percentiles, and does not change the shape or measures of spreads such as the range, the IQR, or the standard deviation. So a large auto dealership keeps track of sales made during each hour of the day. Let X equal the number of cars sold during the first hour of business on a randomly selected Friday. Based on previous records, the probability distribution of X is as follows. So we're going to let the random variable X, the random variable X has a mean, mu sub X, equal to 1.1 and a standard deviation, sigma sub X, equal to 0.943. So the first thing we have to do is suppose the dealership's manager receives a $500 bonus from the company for each car sold. Let Y equal the bonus received from the car sales during the first hour on a randomly selected Friday, and we're going to find the mean and the standard deviation of Y. Before we can begin question 1, we first have to write an equation that represents the bonuses received from the car sales during the first hour on a randomly selected Friday. So we know that we're going to let that be Y because it told us that in the problem, and then we have to create an equation that matches what's happening in our scenario. So we know that a manager is receiving a $500 bonus from the company for each car that he sold. So if he sells 1 car, he gets $500 for his bonus. If he sells 2 cars, he gets $1,000, 3 cars, $1,500, and so on and so forth. So basically, the equation that we would write for that is we would say 500 times X, which represents, of course, the number of cars sold during the first hour of business on a randomly selected Friday. So knowing that that is our equation, we can see that what is happening is we are multiplying our random variable, which is X, by 500. And so having known that, we can figure out what our mean for Y is and what our standard deviation for Y is. So going back to the rules that we learned earlier about multiplying or dividing by a constant. Anytime that we multiply or divide measures of center and location, such as the mean, median, quartiles, and percentiles by B, then that same process happens to the mean, the median, and the quartiles and the percentiles. So for example, on this problem, I am multiplying my random variable by 500, which means that to find the mean for my new equation, I would say 500 times the mean for X. And it tells us that the mean for X is 1.1. So the mean for Y is going to be 500 times 1.1, which gives us 550. All right, using that same concept, I know that if I'm multiplying or dividing by a constant, that you also multiply or divide the spread by the absolute value of b. So I know that if I am multiplying by 500, that I would take the standard deviation for x, and I would multiply it by 500 as well. So I know that the standard deviation for x is 0.943 because it gave me that in the problem of above, and so I could find the answer for that by saying 500 times 0.943, and that gives me 471.5, and because we're talking about money, we would say 0.50. For number 2, it says to encourage customers to buy cars on Friday mornings, the manager spends $75 to provide coffee and donuts. The manager's net profit, T, on a randomly selected Friday is the bonus earned minus this $75. Find the mean and the standard deviation of T. So we know that we're finding T, but the mean for T and the standard deviation for T, but first we need to write an equation that represents T. So we know that we have the bonus that's earned, which is the stuff that we found in y, so the 500 times x, and we have to subtract from that 75. So this represents the equation that is happening whenever it's the Friday where they have the donuts and the coffee. So the first part represents the bonus earned from the manager, and then the minus 75 represents the cost for the coffee and the donuts. So if I'm finding the mu for T, or the mean for T, I would need to refer back to when I am adding or subtracting, because I'm taking the equation and I'm subtracting 75. So whenever I am adding or subtracting by a constant, adds a to the measure of center and the location. So in this case, my A, quote unquote A, is that negative 75. So what I would do is I would take my mean for my equation that we had here, the 500 times x, and which was 550, and we would subtract from that 75. So if I did 550 minus 75, I would get 475. So the mean for T is 475. If I had to do the standard deviation for T, going back to my rules, I see that it does not change the shape or the measures of spread, such as the range, the IQR, and the standard deviation. So for this one, my standard deviation, because I'm subtracting the 75, is going to stay what it was here. So it's going to stay 471.50. And it's also important to note that these are all measurements of money. So when we talk about the mean for Y, that is the average amount of money made on a bonus. And when we talk about the standard deviation, we're talking about how much money away we are from the mean. Effects of a linear transformation on mean and standard deviation. So if y equals a plus b times x is a linear transformation of the random variable x, then the probability distribution of y has the same shape as the probability distribution of x. The mean of y is equal to a plus b times the mean of x, and the standard deviation for y is equal to the absolute value of b times the standard deviation of x. And it's important to note that the b cannot or could be a negative number, and because it could be a negative number, we want to multiply it by the absolute value of b, so that we're always multiplying by a positive number. So in the next example, the problem says one brand of bathtub comes with a dial to set the water temperature. When the baby safe setting is selected and the tub is filled, the temperature X of the water follows the normal distribution with a mean of 34 degrees Celsius and a standard deviation of 2 degrees Celsius. The first thing we have to do for A is to define the random variable Y to be the water temperature in degrees Fahrenheit. And so it's important that we recall that Fahrenheit is equal to 9/5 times Celsius plus 32. The Celsius stands for the temperature in degrees Celsius when the dial is set on baby safe, and find the mean and the standard deviation of Y. So for this problem, what we are going to do is, let's recall that our Y is going to be equal to the formula 9/5 C plus 32. So basically our conversion formula that we would use to convert from Celsius to Fahrenheit. And so we could also write this as 32, and this is really kind of an extra thing, 32 plus 9/5 C. So basically just sorry, I got distracted. The cat just ran through the house like a crazy person. So basically just rearranging our formula, but it all means the same thing. So the mean of Y based on the information that we have here is going to be equal to A plus B times the mean of X. And so the mean of Y is going to be equal to 32 plus 9/5 the mean of X. Which we know that the mean of X is given to us and it's 34. So 32 plus 9/5 times 34. And whenever we work that out, 32 plus 9/5 times 34 gives us 93.2. So 93.2 degrees Fahrenheit. We also need to find the standard deviation for Y. So jumping backwards a little bit, the standard deviation for Y would be equal to the absolute value of B times the standard deviation of X. And so our B in this case would be the 9/5. So the absolute value of 9/5 times the standard deviation of X. And so the absolute value of 9/5, that's the absolute value, not a parentheses, that's my fault. So the absolute value of 9/5 times the standard deviation, which we said was 2. And so whenever you do 9/5 is already positive, so I don't have to worry about those absolute values. So 9/5 times 2, and that gives me 3.6. So the standard deviation for Y would be 3.6 degrees Fahrenheit. B says, according to Baby's RS, the temperature of a baby's bath water should be between 90 degrees Fahrenheit and 100 degrees Fahrenheit. Find the probability that the water temperature on a randomly selected day when the baby safe setting is used meets the Baby's RS recommendation, and show your work. All right, so one thing that we need to keep in mind is that the linear transformation does not change the shape of the probability distribution. And we learned that back here when we were talking about the effects of linear transformations on the mean and the standard deviation. So because we know that the linear transformation does not change the shape of the probability distribution, the random variable Y is normally distributed with a mean of 93.2 and a standard deviation of 3.6. So going back to what we did in part A. All right, so we want to find basically the probability that the temperature is between 90 and 100. So it can be 90, it can be 100, and anything that falls in between there. So you could use your z-score and your standard normal table in order to find that. You could also do it on the calculator. So if we did it on the calculator, we would basically be finding the area underneath the curve that fell between 90 and 100. So we would do second bars and do normal CDF. Our lower bound would be 90. Our upper bound would be 100. It tells us that our mean, remember we're going to use the mean from part A, so that was 93.2. And our standard deviation, we're also going to use the standard deviation from part B, which was 3.6. And so then we would just work that out on the calculator, and we would get 0.7835. So this is approximately 0.783, which is pretty much 78%. So that means that there's a 78% chance that the water temperature meets the recommendation on a randomly selected day. Mean of the sum of random variables. So for any two random variables, x and y, if t equals x plus y, then the expected value of t is equal to the mean of t, which is equal to the mean of x plus the mean of y. In general, the mean of the sum of two random variables is the sum of their means. An independent random variable is basically when events x and y are independent, if knowing whether any event involving x alone has occurred tells us nothing of any event involving y alone, and vice versa. So the sum of random variables, this is an example that kind of goes along with that. So earlier we examined the probability distribution for the random variable x equals the number of passengers on a randomly selected half-day trip with Pete's Jeep Tours. Here's a brief recap. So we said this was our table of probabilities having to do with the number of passengers, and we knew what the mean was and what the standard deviation was for when we were talking about those passengers. Pete's sister Erin, who lives near a tourist area in another part of the country, is impressed by the success of Pete's business. She decides to join the business running tours on the same day as Pete in her slightly smaller vehicle under the name Erin's Adventures. After a year of steady bookings, Erin discovers that the number of passengers Y on her half-day tours has the following probability distribution. And so then you have this distribution. So we're going to let t equals x plus y as before and assume that x and y are independent random variables. We'll begin by considering all the possible combinations of the values x and y. So then we have this table, and our x's are possible passengers for Pete's Jeep Tour, and the Y are possible passengers for Erin's Adventures, and the P is the probability that goes along with those. So, like in the first row, we see that the first row has to do with 2 passengers for Pete's, 2 passengers for Erin's, and so the expected value would be 2 plus 2, which is 4, and then we would, to deal with those probabilities, we would multiply the probability from Pete's and the probability from Erin's, and we would get 0.045, and so on and so forth. Now we can construct the probability distribution by adding the probabilities for each value of t. For instance, the probability that t is equal to 6. So if we look at, if we were looking for probability that t is equal to 6, then we would use anything that would add up to give us 6 people total. So, like, we couldn't use any of these. We could basically mark through the ones that we can't use. So we can't use this one. We can't use 2 and 3. That makes 5. We could use 2 and 4, so that one would be okay. Actually, let me just do this. Let me just highlight. You guys know I'm not very good with the, like, drawing shapes. Not that I'm great at highlighting, but it's a little better. 2 and 5 we couldn't use because that would make 7. 3 and 2 would make 5. I could use 3 and 3, so that one would be okay. 3 and 4 is out. 3 and 5 is out. 4 and 2 would be okay because that adds up to give me 6. 4 and 3 does not. That one's out. That one's out. 5 and 2 would be okay. 5 and 3 is out. 5 and 4 is out. 5 and 5 is out. 6 and 2, 6, 3, 6, 4, 6 and 5. So all of the rest of those are out. So basically I would only have 4 that would actually work. Oh, wait, actually, this one won't work because that's 7, and we needed it to be 6. Sorry, my fault. So we would see that we have 3 different times when that would work, and so what we would need to do is we would find the probabilities for each of those events, and that would be taking the probability of Pete's and multiplying it by the probability of Aaron's and getting the probability that they happen at the same time, and then just adding those all together to get 0.235. And so what they show you down here in this little table thing is these are the values that of t. So basically, if they have 4 passengers total, 5 passengers total, 6 passengers, 7, 8, 9, 10, 11 passengers total. So that would be people that were on Pete's Jeep tour and Aaron's adventures, and finding the probabilities that went along with that. As the preceding example illustrates, when we add 2 independent random variables, their variances add. Standard deviations do not add. For Pete's and Aaron's passengers total, you would find, I have no idea why this is super small. You would have to say standard deviation for X plus standard deviation for Y, and then just add them together. But however, that's quite different from the standard deviation for what we have here in this table. Variance of the sum of independent random variables. So for any 2 independent random variables, x and y, if t is equal to x plus y, then the variance of t is the variance of t is equal to the variance of x plus the variance of y. In general, the variance of the sum of several independent random variables is the sum of their variances, which is a lot harder to actually say than this right here. So if you want the variance of the total, then you would add up the variance of each one. So a college uses SAT scores as one criterion for admission. Experience has shown that the distribution of SAT scores among its entire population of applicants is such that we have the SAT math score of X, the SAT critical reading score of Y, and so then you have the mean for each of those and the standard deviation for each of those. What are the mean and standard deviation of the total score X plus Y among students applying to this college? So basically, if you were finding T, the T would be the X plus the Y, so the total score would be your math plus your critical reading. And so if we were finding the mean of T, then we would do the mean of X plus the mean of Y, which would be 519 plus 507. And whenever we added those together, we would get 1,026. It also asks us to find the standard deviation. It is important, though, to remember what we said about the standard deviation, and that's for any two independent random variables, x and y. Then we would add up their variances together. It's also important to note that when we look at this example, the scores for your math score and your reading score are not going to be independent. And so therefore the variance in the standard deviation of the total cannot be computed from the information given. Basically what it means is because students who score high on one exam tend to score high on the other also, then we can't say that these two are independent, and so we can't find the standard deviation. Because basically x and y would depend on each other. All right, so going back to Pete and Aaron's tours. Earlier, we defined X to equal the number of passengers on Pete's trip, Y to equal the number of passengers on Aaron's trip, and C to be the total of money that Pete collects on randomly selected days. We also found the means and the standard deviation of these variables. So for A, it says Erin charges $175 per passenger for her trip, and we're going to let G equal the amount of money that she collects on a randomly selected day, and we want to find the mean and the standard deviation of G. Alright, so if we think about A, we first have to write an equation that would represent G, the amount of money that she collects on a randomly selected day. So what we would need to do for that is we think about, okay, if she has one person that goes, it's $175. If she has two people that go, she would have $175 two times, which would be $350. If she has three people that go, it would be $175 three times. And so what I'm basically doing is I'm basically saying 175 times Y. And I have to use Y because Y represents the number of passengers on Aaron's trip. Alright, so if I wanted to find the mean for G, I would find the mean for G by saying I took my random variable Y and I multiplied it by 175. So because I multiplied it, I would say 175 times the mean for Y. And I use Y because that was my random variable that I used in my equation that I wrote for G. So what that means is I would say 175 times the mean of Y, which is 3.10. And so 175 times 3.10 gives me 542.5. So what that basically means is that she can expect to make $542.50 from her trip on a randomly chosen day. To find the standard deviation for G, I would be saying 175 times the standard deviation for Y, and that's because, remember the relationship that standard deviations have whenever you are multiplying or dividing by a constant. And so I would say 175 times the standard deviation for Y, which was 0.943. And so if I work that out, 175 times 0.943 would give me 165.03. So this 165.03 would represent basically the distance from the mean. All right, for B, it says calculate the mean and the standard deviation of the total amount that Pete and Aaron collect on a randomly chosen day. So for this one, it doesn't tell us what we want our random variable to be. So let's let it be, let's just do something like W. So we're going to let W equal the total amount collected. And that would be from Aaron and from Pete together. And so to get W, if we know that this is a total amount that was collected from Pete and from Aaron, then it would be C plus G, C representing Pete and G representing Aaron. So we know that the mean of the sum of the two random variables equals the sum of their means. And so we found that out a few slides back. And so basically, the mean for W would equal the mean of C plus the mean of G. We know that the mean for C, which is recorded up here, is 562.50, and we found out that the mean for G was 542.50. And so if we added those together, we would get 1,105. So the mean collected together is 1,105, which means that together they could expect to collect about $1,105 per day. All right, it also asks us to calculate the standard deviation. And so if you think about, this is happening in two separate parts of the country. You have Pete's on one side and Aaron's on the other. And so basically, what happens with Pete's is not going to affect what happens with Aaron's because they are totally unrelated. And so what you would need to do for this one is you would say first that X and Y would be independent. So what happens with Pete's, which is X, does not affect what happens with Aaron's, which is Y. They have no relationship to each other. So what you would do to find the standard deviation, you would find the standard deviation, actually you'd start with the variance, so let's start with that. So you'd find the variance for W, and that would be the variance for X. Actually, this was C. C represented the amount that was collected. X represented Pete. So the standard, or the variance for what Pete collected, plus the variance for what Aaron collected, which we let be G. And so to find the variance for those, we would find the standard deviation, which we had listed up here, for Pete, which was 163.50, so 163.50, but we'd have to square it. That's what happened here. And then we found the standard deviation for Aaron, which was 165.03, and we would need to square that as well. And if you worked that out, 163 point, actually let me do this. 163, really? 163.50, close your parentheses, squared, plus 165, oh my God, plus 165.03 squared. Since that took me 10 minutes, you would get 53,967.1509, but because we're talking about money, we would just say 0.15. So the answer for this would be 53,967.15. That represents the variance, though. So in order for us to find the standard deviation, remember that the relationship that the variance has with the standard deviation is you take the variance and you square root it to get the standard deviation. So the standard deviation for W would be the square root of 53,967.15. And that would give us 232.30831, but because we're talking about money, we would round that up to 0.31. So 232.31. So basically that means that the standard deviation of the total amount that they collect would be $232.31. All right, check your understanding. So a large dealership keeps track of sales and lease agreements made during each hour of the day. Let X equal the number of cars sold and Y equal the number of cars leased during the first hour of business on a randomly selected Friday. Based on the previous records, the probability distributions of X and Y are as followed. So X is the cars sold, and the probabilities are below that. And Y is the cars leased, and the probabilities are below that. So first we want to define that T equals X plus Y. So T being the total of cars that were handled at the dealership for that day, and the X and the Y being the sales and the lease agreements, and the total of that, adding those together. So the first thing we have to do is find and interpret the mean of T. So for number one, if we're finding the mean of T, we would need to find the mean of X and add it to the mean of Y. So the mean of X we know is 1.1. It told us so here. And the mean of Y is 0.7. It told us so here. So I would just add those together, and I would get 1.8. When it asks us to interpret that, on average, this dealership sells or leases 1.8 cars in the first hour of business on Fridays. Number two, ask us to compute the standard deviation of T, assuming that X and Y are independent, and show your work. Alright, so whenever we have to compute the standard deviation for T, assuming that X and Y are independent, we have to remember that back a few slides we said that standard deviations do not add. This is very important. So even though that the two events are independent, we can't just add them together. We do know, though, that their variances will add if we have two independents. And we know that the variance and the standard deviation are closely related because I just have to find the square root of the variance to get the standard deviation. Now, that's a long, drawn-out process to get the standard deviation for T, but that's what I'm just going to have to do. So I'm going to say, I'm going to first find the variance for T. So the variance for T would be the variance squared for X plus the variance squared for Y. Or the standard deviation squared for X and the standard deviation for Y. Alright, so the standard deviation for X was 0.943, and we have to square that. And then we're going to do the standard deviation for Y, which is 0.64, and square that as well. Because I want to get the standard deviation, I would do the square root of 0.943 squared plus 0.64 squared. So, on the calculator, I would do the square root of 0.943 squared plus 0.64 squared. And whenever I do that, I get 1.39, which is essentially 1.14. Three says the dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and the standard deviation of the manager's total bonus, B, and show your work. So the first thing that you have to do for this one is you have to write an equation for B. So B is the total bonus that was received whenever the manager got a $500 bonus for each car sold and a $300 bonus for each car leased. So the equation that we would write for that is we would say he gets $500 per car plus $300 per car leased. So X car sold, Y car leased. Now, because I'm multiplying by 500 and by 300, the X and the Y respectively, then that would mean I would say 500 times the mean of X plus 300 times the mean of Y to get the mean of B. From my problem, I know that the mean of X is 1.1. It told us so up here in this table. And then I know that the mean of Y is 0.7. So plus 300 times 0.7. Let me put this one in parentheses too. So on my calculator, I would say 500 times 1.1 plus 300 times 0.7. And whenever I do that, I get 760. All right, it also asked me to find the standard deviation for B. So to find the standard deviation for B, we can assume that X and Y are independent. And so we would need to, for this one, it tells us we're assuming that X and Y are independent. That's why we assumed that they were independent. But it tells us that we need to find the standard deviation. But remember, we can't find the standard deviation for two independents. We have to find first the variance and then take the square root of that. So to find the variance for this problem, we're going to say 500 squared times the mean, or the standard deviation, I'm sorry, for X, which was 0.943, which is what they told us up top. And that's going to be squared plus 300 squared times the standard deviation for cars leased, which was 0.64. And that's also squared. And I'm finding the square root of all of that. So that's going to give me the standard deviation. Square root of 500 squared times 0.943 squared plus 300 squared times 0.64 squared. So I can plug that into the calculator just like it looks. So square root 500 squared times 0.943 squared plus 300 squared times 0.64 squared. And that gives us 509.093557. Because we're talking about money, we would say 509.09. 509.09. And this would be in dollars. The mean of the difference of random variables. So for any two random variables, x and y, d equals x minus y, then the expected value of d is the mean of d, which is the mean of x minus the mean of y. In general, the mean of the differences of several random variables is the difference of their means. Variance of the difference of random variables. For two independent random variables, x and y, if d equals x minus y, then the variance of d is the variance of x plus the variance of y. We have defined several random variables related to Pete's and Aaron's tour businesses for a randomly selected day. So it reminds us that x equals the number of passengers on Pete's trip, y represents the number of passengers on Aaron's trip, c is the amount of money that Pete collects, and g is the amount of money that Aaron collects. And then it gives us the means and the standard deviations for each of those. The problem asks us to calculate the mean and the standard deviation of the differences for d equals c minus g and the amounts that Pete and Aaron collect on a randomly chosen day, and interpret each value in context. So using the information that we just learned about to find the mean for d equals x minus y, you would say the mean of d would equal, this should be flipped. The mean of d equals the mean of c minus the mean of g. So we know that the mean of c is 562.50, and the mean of g is equal to 542.50, and we would just subtract those. And when we did that, we would get 562.50 minus 542.50, 20. So what that means is, on average, Pete collects $20 per day more than Aaron does. Some days the difference will be more than $20. Other days it will be less, but the average difference after lots of days will be $20. Since the number of passengers x and y are independent random variables, we already determined that they are in two separate parts of the country, and so what happens on Pete's does not affect what happens with Aaron's trips. Because these two are independent, the amounts of money collected, C and G, are also independent. Therefore, the variance of D, if I were finding the variance for D, would be equal to the variance for C minus the variance for G. So I know that the variance for C would be 163.50 squared minus the variance for G, which would be the standard deviation 165.03 squared. Remember, I can't straight out find the standard deviation by adding those together, but I can calculate the variance and then take the square root of that. And so if I were doing this, I would say 163.5 squared plus 165.03 squared, And so I would get 53,967.15. And that would represent the variance, but I need to take the square root of that in order to get the standard deviation. So 232.31. So basically what that means is the standard deviation of the difference in the amounts collected by Pete and Aaron is $232.31. Even though the average difference in the amounts collected is $20, the difference on individual days varies somewhat, but by how much? And that would be approximately $232. Check your understanding. So going back to the example that we talked about with the cars sold and the cars leased, and it gives us that information there. And we want to, it doesn't say what you need to do for this one on the slide. I'm hoping that it does in your notes. If it doesn't, what you need to do is you need to define that D equals X minus Y. And for number 1, we want to find and interpret the mean of D. So if we are finding the mean of D, we would have to say the mean of X minus the mean of Y. So you know that the mean for X is 1.1, the mean for Y is 0.7. And so you would just subtract those, and whenever you did, you would get, let's see, 1.1 minus 0.7, 0.4. Basically what that means is on average the dealership sells 0.4 cars more than it leases during the first hour of business on Fridays, on a selected random Friday. The second question is you are going to compute the standard deviation for D, assuming that X and Y are independent, and show your work. All right, remember that you can't straight out find the standard deviation for D, so you're going to have to find the variance for D first and then take the square root of that. So the variance for D would, you would get that by taking the standard deviations for X and Y and squaring them. So the standard deviation for X squared plus the standard deviation for Y squared. The standard deviation for X would be 0.943, and you would square that, plus the standard deviation for Y, which is 0.64, and you would square that. So when you did that, you would see that together you would get 1.2, actually 1.30. But that would be the variance, not the standard deviation. So to find the standard deviation, you would take the square root of 1.3 So the square root of 1.3 would be 1.41. Or 1.14. All right, for question 3, it wants you to find. It tells you that the dealership's manager receives a $500 bonus for each car sold. And then it tells you that he gets a $300 bonus for cars leased. And we want to find the mean and the standard deviation of the difference in the manager's bonuses for the car sold and the cars leased. So we know that B is going to equal the 500 times X plus 300 times Y. I think we did this one earlier, or did this something similar to this earlier. So if we need to define the mean for B, to find the mean for B, we would say the mean for X. Oh, this should be minus in between. Minus the mean for Y. So the mean for X we knew was 500 times 1.1. And the mean for Y we knew is 300 times 0.7. So 500 times 1.1 minus 300 times 0.7 would give us 340. So $340 is the difference in the bonuses for cars sold and cars leased. We also need to find the standard deviation for the bonuses. Remember, you can't find the standard deviation for the difference in the bonuses. You have to first find the variance and then take the square root of it. So to find the variance for the bonuses, you would say 500 squared times 0.943 squared plus 300 squared times 0.64 squared. So whenever you work that out, and that would give you 259,176 and a quarter. But you need to find the square root of that because that gives you the variance, not the standard deviation. And whenever you do that, you would get 509.09. So the standard deviation for B would be the square root of all of that stuff. Which we know would be 509.09.